Hey guys, I'm Avirokth and I recently came across this amazing book called Data Engineering Design Patterns, and I thought some of the concepts covered in this book to be really fascinating. I mean, as data engineers, you guys would have probably heard from a lot of people that you got to be proficient in different data engineering tools such as your standard SQL or Python and tools such as Snowflake or Databricks, right? But nobody actually tells you how to bring them all together and use them to your advantage at certain situations. No matter how good you are at coding or how good you are at using these tools, at the end of the day, it all boils down to your basic design architecture. And keeping that in mind, I wanted to focus on some of the concepts covered in this book. So today I wanted to cover concepts related to data ingestion uh, that include your full loads, your incremental loads and stuff. So let's get right into it. So first things first, let's go ahead and discuss some of the patterns that were design patterns that were discussed in chapter 2. I didn't really want to talk about chapter 1 because I felt like it was pretty introductory and nothing of much importance was covered there. So the first concept that we're gonna cover today is your oh my bad is your full load, right? So what is a full load? Basically, it's the most simplest way to move data, right? All you're doing is just copying your entire data set from your source system to your destination. So it's just an exact mirror of the source at the destination. So how do you do this is you truncate or you delete all the rows that are present in your destination, and then you create a replica of the source system at the destination. So to kind of visualize this, I have something here. Let me just make a few changes here, right? So let's say you have two databases or two tables. I'll say maybe you have at the source you have maybe like an S3 object storage in the form of parquets or CSVs or whatever, right? And you want to load all the data that is getting accumulated at the source to your bronze. So what do is, let's say you have accumulated 480 records today, that is the 14th of January, and there is the same amount of records in the bronze layer 2 from yesterday, right? So when you are running such pipelines every day, so what you do is, so on the 15th of January, this is what you do. You first truncate the rows or the data that you have in your bronze layer, and then you create an exact copy of the data that is present in your source. And now the bronze layer can go ahead, the consumers can go ahead and access data from the bronze layer. And this can change to maybe like 15 Jan or something, right? And you do the same thing. So at that point in time when you are ingesting data from your source, all you do is you look at the data in your source system, and all you do is a simple copy to your bronze layer or your staging layer at your destination. So again, it's just a simple truncate and then a copy, right? So at what situations or why do we even have to use a full load, right? The first point that sticks out is simplicity. You guys would have probably seen that to do this entire operation, we didn't have to write a complex code, right? It was just two statements. You just had to remove the rows that were in your bronze layer, and then just had to copy the data from your source. So simplicity is key. So you didn't write complex logic to detect changes. So I'll talk about CDC later, but for now, just assume that you aren't doing complex complex tasks just to get data from your source to your branch, unless if you want to have like a transformation layer in between where you want to like handle schema, the design and schema or something. So but yeah, like this is like the most simple scenario where you're just copying data from your source to your branch layer or your destination. So when we talk about self-healing and being idempotent, what I mean is every time you are copying data from your source to your branch layer, you are producing exactly this. You are exactly copying the same data, right? You're not making any changes. So let's say if you had if you had deleted 10 records from your source system, the same amount of data is going to get copied to your bronze layer. So there is consistency between the data that is present in your source and your destination, right? So this is what being idempotent means, that if something fails, you just have to run it again, and then you're going to end up with the same result. Now, is it ideal? Hell no, it is not ideal at all times, because in the world of big data, we're essentially not dealing with only 470 records, right? We're dealing with millions of rows. So let's say you started an e-commerce business, and on day one you ended up getting 10 orders, right? But that it doesn't mean that even after a year you're still gonna be getting 10 orders, right? As your business grows, the number of orders you get also increases. So as the number of orders increases, the data that you are collecting also increases. Let's say on day one I had provisioned a cluster, a small cluster. A cluster is basically storage and compute coupled together that will help perform this load. So extra small warehouse in Snowflake terms means the smallest amount of compute and storage that you get. So when you were having like less number of records, you needed a small cluster. So you had provisioned a small cluster in the beginning. As and when your business grew, you started getting 10,000 orders every day. So now what happens is your small warehouse cannot really handle your large data, right? Because the storage in your cluster is going to be pretty limited. It cannot handle 10,000 records. So what happens is you end up with an error called the out of memory error, due to which your pipeline breaks. So in order to solve this problem, the author basically suggests that we use something called as auto scaling. So every time your data increases in your source system, you increase your compute power too, right? So maybe go from an extra small to a medium, and go from medium to a large warehouse. So this process is called vertical scaling. So you're increasing the capability of your cluster, or you're giving it more superpowers, right? So let's say you had 4 gigs of RAM, and now you've increased that RAM to maybe 10 gigs. So you're giving more power to your resources. So but is this ideal? I mean, hell yeah, it is ideal if you have a lot of money, but at the end of the day, it's all about staying efficient and cutting costs, right? So this does work. I mean, if you have like a lot of money to spend, then sky's the limit, right? Like you can go ahead and choose or provision the best of the best resources to help move your data from your source to your bronze layer. But it is not ideal if you want to like save costs or save money. So the author talks about something here that it was really fascinating. uh, what happens is, like, basically when you design systems or when you design data architectures, you have like a data model, right? So let's take an example of a star schema here. And for example, your business had your e-commerce business, for simplicity's sake, I say you have like 3 tables. So you have 2 dimensional tables and 1 fact table, right? So your dimensional tables are not accumulating data like as fast as compared to your fact tables, because let's say you are getting 100,000 orders every day, because you have a pretty successful e-commerce business. But it doesn't mean that you are adding 100,000 products or 100,000 sellers every day to your dimensional tables. That's the basic idea of your star schema. I mean, you guys could go ahead and read this amazing book by Kimball. I think I have that book with me too. It's called The Data Warehouse Toolkit. If you want to know more about data modeling, then this is a good book. So since your dimensional tables are not accumulating a lot of data, you can go ahead and use your full loads on such tables. But using full loads on tables such as your orders is not very optimal, because like I said, as your data grows, the number of the processing time, or the amount of time it takes to bring data from your source to your destination also increases. So and if you want to speed up that process, then you have to like increase your your resources that you had provisioned earlier, and because of which you end up incurring a lot of costs too, right? So in order to save costs, avoid using full loads on tables that are fast accumulating, and just use them on dimensional tables. So yeah, that's what I really wanted to talk about some of the cons of using full loads and how you can like overcome them. So next up, I thought this was really interesting. The author talks about single data exposition, right? So what happens in this scenario is, I'll give you guys a brief of what's going on. So let's say that you had your destination or your staging area, right, to where you're basically writing data from your source. I just call it destination. So what happens is, when you are writing data to your staging area, at the same time, this is not where your data ends, right? Like you still have to move this data that is present in your staging area downstream, where your consumers or your stakeholders are going to access this data. They're going to make use of this data, like maybe data analysts or data scientists or machine learning engineers are going to build machine learning models with the data that is present here. So what happens is, when you are writing data to your destination, you're also, if you concurrently start reading from this destination, so what happens is you end up reading partial data, right? So let's say at 9 a.m. You ran your pipeline at 9 a.m. and you had 100 MB of data, right? So at 9:05, let's say you have only copied or written maybe 20 MB of data. So when the consumer is reading from your staging table, the consumer is only reading partial data, right? He only has access to this 20 MB of data. And because of which, if let's say if the consumer was a data analyst and was building dashboards, so when the stakeholders look at these dashboards and they are and the dashboards are representing only partial data, then the stakeholders cannot make effective decisions, right? So in order to solve this problem, we have transaction rules. So what that says is that when you are performing a write, you do not perform like a read. So you do not perform a read. You just like you wait for the write to finish, and only after the entire 100 MB has been written to your destination, you start reading from this source, right? So this is the basic idea. But do you think this is efficient? Because let's say you had a lot of data, like petabytes of data, right? It's not going to write in 5 minutes or 10 minutes, right? It's going to take hours sometimes to finish writing. So when the writing takes so much time, then the consumer at this end is going to be idle. So to solve this problem, we use something like this. We come up with basically two staging areas. So what happens is in one of the staging area, you write data, and you write data to one of the staging areas, and from the other staging area you do a read. So this could be data from yesterday, and this could be the data that is being written for today. So after this process right here is finished, right, after you have finished writing your data to your second staging area, what you can do is then you can get rid of this, right? You can just get rid of this and end up reading from this. So this was the basic idea of using two staging areas in order to, make sure that the consumer is not idle. So this is called a single data exposition abstraction. So next up, I think we're going to be talking about incremental loads. So now let's go ahead and discuss incremental load, right? The difference between an incremental load and a full load is that in full load you're basically copying the entire data from the source to the destination, but in incremental load you're not copying everything. You're only copying maybe records from a particular point in time, or you're processing only the data that has been created or modified since the last run. So how do you do this? Basically there are two ways that you can enforce an incremental load. One is usually it's called the delta method, I think. Yeah, it's called the delta method, and it uses watermarks, and the other one is the partition based method. So let's just get deep into these concepts now. So first, let's talk about let's talk about the delta method or the watermarking method. So what's gonna happen here is that so let's say you have this is your source, right? You have your source system, and then you have your my bad guys, I think my PC is just bugging. So like I have to I have like literally ordered a new PC right now, and I think it's about to get delivered today or something, but I'm using like an old gaming laptop, which is like which is like going crazy right now, right? So don't worry about that. Just like hold on with me for a moment, and trust me, things are gonna get way better after this. So first, let's talk about your delta loads, right? So you use a watermark. So what you do here is that essentially, let's say you ran your pipeline at 9:05 a.m., right? Let's say at 9:05 a.m. This timestamp can be your ingestion time to your source system, or you can say creation time or whatever, right? Doesn't matter. It's the same thing. So what happens here is that first, when you run your pipeline at 9:05, you have to go through these two steps, right, to copy your data from your source to your destination. So what we're doing first is actually there's actually a better way to do this. Wait, let me tell you guys how this is done. So what you can do here is that you can use maybe for the first run you can use the coalesce function, and it can be the max of your ingestion time and maybe an older date, right? Let's, for simplicity's sake, let's say 1900 0101. Okay. So forgot an extra. No, yeah, I think this works. Yeah, it works. So what you do here is that for the first run, first you have to set your watermark, right? Your last watermark. For the first run, when you don't have any data in your target destination, so what you do is you run the first statement, which is you're basically checking if either this time or this time exists, right? So at first you don't have my bad, I'll just move this. Okay, now that's out of the way. So first you have to select the max of ingestion time, right? But guess what? Wait, so this is like the ingestion time for your I mean, let's not call this ingestion time, because then you guys will probably get confused. So let's say the creation time at the source was this, right? But now we can call this ingestion time here, the time at which the record was ingested into your target. But guess what? The very first run, you don't have any records here, right? You don't have any records at all. So what you do is, since you don't have any record here, you set the last watermark to an earlier date. So the last watermark right now for the first run would be this date, right? 1901 and 01, right? So the last watermark for the first run would be this earlier date. Now you go to the second whatever step. So it's basically simple. What you're doing is you're picking up these records and you're doing a comparison where you're checking if the ingestion time or whatever time that was, like, or maybe let's say creation time is greater than the last watermark. So Of course, like for simplicity's sake, let's include the date as well, because it's let's say 12th Jan 2026, and this one's at 12th Jan 2026 too. Maybe I could say 12/01/26. That would be better. Oh man, just to keep everything consistent. So that it's clear for you guys to understand. So yeah, so the ingestion time at the source, you can see that it is obviously greater than this date, right? So 2026 is 126 years later compared to this timestamp right here. So what do? You pick these rows up, right? You pick these rows and you add them here. Oh man, why my PC started bugging again? Just give me a moment, guys. Okay, great. So now that you have ingested basically what you're doing is a full load, right? You're just copying everything that was there in your source to your destination. So that's why I told you that the very first run that you do is basically like a full load. So now let's get this out of the way. Now let's say you had another record come in at maybe I don't know, Jake, let's say Jake, on the same day, that is 2026, let's say 2026, or maybe on the 2nd of Jan, right, at maybe 10 a.m. Now when you run the pipeline the next day, that is on 2nd Jan, so what happens is that in full load, you would what you would basically do is you would just truncate all the records in your destination, right? You would just remove John, Mary, and then you would just copy all the data that is here into your destination. Like I said, full loads for a limited number of rows is okay, but for like millions of records, it's not optimal, right? We discussed the major drawbacks of full load in the previous section. So now what incremental load does is, let's go through the second iteration, or the pipeline that's going to run on the 2nd of January, right? So now you do last watermark of coalesce. The first thing here is max ingestion time, right? So you have your ingestion time right now. See, you have your ingestion time at your destination. So what's the max ingestion time right now? It's this one, right? It's obviously this one, the second record. So now your last watermark becomes this. Right? And now what you do is you go to step 2. In step 2, you basically you insert records into into your destination, where the ingestion time of the source, I'll just make this dot source. I mean, this ingestion, don't get confused with the ingestion time written here. This is the ingestion time of the source. So we'll check that the ingestion time at the source is greater than the last watermark. Now we're gonna go through every row right here. Of course, the first record is not greater than this watermark. The second ingestion time is also not greater than this watermark. But the third one, which came in today at on the 2nd of January, is definitely greater than the last watermark, right? So what you would do is you would just insert this record now here. So this is what you're doing in an incremental load. You're not copying the whole data from your source to your destination. You're just copying the data from a particular point, which is like your last watermark. So when you're doing stuff like this, you are processing less number of rows, right? Let's say you had let's take your e-commerce, your business, for example. Let's say you throughout history, you've completed 100,000 orders, and your fact table has 100,000 orders, right? So every time you get a new order, or you get a new set of orders, you don't have to copy the entire 100,000 records again to your staging or your destination. You just have to copy those new orders that you received recently, so that the number of rows that you're the number of rows, or the number of the amount of data that you're processing is limited, right? And in order to do so, you're basically, you're not using a lot of compute, right? Because you're only dealing with a small number of rows or data. So this is one method. It's called the delta column. So the delta column here was basically the timestamp column, right? And now this is best for data in databases, right? In traditional databases, like your it could be your analytical OLTP systems, or transactional databases. So now let's talk about the other method. Usually, not all kinds of data is coming from like your OLTP system, right? So now you have something called as the partition based method. So let's say you have your data lake, or you can call it your it could be your Amazon S3 object storage, or it could be your Azure blob storage. I don't know what it's called in GCP, but yeah, like you get the idea, right? For simplicity's sake, I'll just call this S3. So you have your S3, right? What's like the most efficient way to store data when you are when you're getting data from wherever you're collecting data from, maybe your application or whatever, right? So that job is usually done by software engineers. They design how data is collected and stuff. So as a data engineer, let's say you have an S3 object storage space here, and now you have partitioned your data according to, let's say, date, right? It's one of like the efficient ways to do things. So you have a file. It could be anything like a Parquet or CSV or Avro or whatever, right? So you have a file, so you just drop that file into your object storage. So you have, let's say, 3 files, and let's say this was at 2026-01-01. This file, though, the first file basically has all the data for the date 2026 Jan, the 1st of Jan. So, and the second one has all the data for the 2nd of Jan, and then the third one has all the data for the 3rd of Jan, right? So what you're basically doing here is that you are this is something similar to your delta load too, but here you're dealing with data lakes, so you're dealing with files or folders or whatever. So now what you do is for the first run, again, same, you have like a watermark where you set it to a previous date, maybe like the 1st of January 1901 or 1900s. So first what you do is you give me a second. Let's see this right. So what you're doing is you are basically ingesting the first file, right? You're ingesting the first file, which was generated on the 1st of January 2026. Now, when you run the pipeline again on the 2nd of January, when you do a traditional full load, you generally have to copy everything that's there in your source, right? So if you do a full load, you'll end up copying both the data for second and first, but here you don't copy the data for the first. You're only copying data for the 2nd of January. And similarly, when you run your pipeline on the 3rd, you're not copying everything that's there in your object storage. You're only copying the most recent data. So this is called partition based incremental load, where you are not loading everything that's there in your in your source, and you're only ingesting data that have modified or were inserted like recently, or are basically new records, right? So this is where you use incremental loading, and this is how it solves that problem of full load, where you don't have to like use a lot of compute to load everything that you have in your source to your destination. So in the textbook, it basically talks about this extensively. You guys can like go and read about it and understand how this thing works. So yeah, this is how this is what I was talking about. So you have a record at an ingestion time of 9:59 and 10:01. So let's say your last pipeline ran at 10 o'clock. So the new records that now need to be processed are the records of 10:01 and 10:02, right? So after you finish this, you set the max of this. The max of this is basically 10:02. In partition, you basically have multiple files, and each file has like a timestamp attached to it, and you only process that file every time you run your pipeline. Now, talking about the, I think you guys cannot see the content on the screen properly, so let me just move this here, right? Yep, the backfill. Sure. Okay, so what are some of the problems of your incremental load? So now there's something called as backfilling, right? So let's say you want to copy everything, or you want to run your pipeline again for the past 2 months, because of, it could be for a variety of reasons. Maybe there was an error and you wanted to fix that, so you do a backfill. Now the problem is, when you do a backfill, you'll end up doing something. You'll basically end up doing a full load, right? Let me give you an example. Let's say you have you have data from the past 2 months. I think I can take this example itself, right? Right. So let's call this as Jan, Feb, and March. So let's say you're currently in you're currently in March, right? And you have basically loaded all this data into your destination, because you're currently in March, so you have already processed previous data. Let's say in Jan you had around, you had around 1,000,000 records, and then in Feb you had around, I don't know, like 700k records, and then in March you had around 400k records, right? So now what happens is that, let's say your manager or the stakeholders sees there's some error in the previous pipeline runs, and he asks you to fix it. And once let's say there was some error that in your pipeline in January, right? So you will have to go back to January and load everything from January up until today, right? So when you're doing that, you're essentially doing, you're essentially end up doing a full load, right? You have 1,700,000 and 400k records. That's like 2.1 million records, right? 2.1 million records while doing a backfill from Jan. So you'll have to end up copying 2.1 million records. Now if your resource or if your compute doesn't have the power to process 2.1 million records, then obviously it's going to throw an out of memory error and your pipeline is going to break, right? So what do you do in such situations? In such situations, you again do the same thing. You break your data into windows. Maybe let's say first you process only data for January, and then second you process data only for Feb, and third you process only for March. Is this ideal? It's not ideal, because it is going to take a lot of time because you're doing a historical backfill. But the advantage here is that your pipeline will not break, right? So this is one con, or one way that you can deal with the situation when you have to do a historical backfill. And the second one, which I felt really interesting, was this idea of ghost records. So you might be wondering what a ghost record even means, right? So let's say that I'll maybe take this example right here, right? Oh my god, my PC is just bugging again. So I'll just add new items right here, right? That's better. So you have your source system, you have your source system here, and then you have your your destination. Oh my god, what's happening? Yep. So you have your source and your destination, right? I wanted to bring this example too, so that it's going to be easy for you guys. So this is how it looks like in the beginning. So you have your records in your source system, and then you do an incremental load, and then after maybe 10 o'clock you end up having all the three records, right? You end up having all three records, right? So after 10 a.m. you have all these three records in the destination as well. Now what happens is, let's say maybe like Mary deleted her account. She doesn't want to she doesn't want to be a part of your e-commerce site anymore. So she removed herself from your website and her record got deleted. Now the problem is, when you do an incremental load, you're basically saying you're basically telling that you want to only you only want to consider records that are greater than the max of which are greater than the max of the timestamps here, right? So you only want to, like, next time, let's say I'll give you an example. Let's say Mary deleted her account, and then there was another guy called just give me a second, guys. Let's say there was another guy called oh my god, okay, so I hope it works now. Chrome is always bugging because when you have multiple tabs open, it's just like, it's a problem. So let's say you have another like, you have another user called Messi who just signed up to your e-commerce business, and on what date? Maybe let's say 2026, or like on the 3rd of January, right? Let's say at the same time. Now what happens is that when you do an incremental load, you're basically only checking for the last watermark. The last watermark is basically the max of all the timestamps that are present in your destination, right? So the max of the timestamp here is basically this one, the last record, right, which is 10 o'clock on the 2nd of Jan. Sorry, yeah, the 2nd of Jan. So what you do is you compare that here, and you find all the records that are greater than the ingestion time here, right? So of course John and Jake are already present in your destination, so you don't consider them. Only Messi, who signed up on like the 3rd of Jan, has his timestamp greater than the max of the ingestion time here, right? So you only copy Messi to your to your destination. Okay, so now what's the problem here? Oh, sorry guys. I hope let me check when my new PC is getting delivered, because it was supposed to get delivered today. Anyway, now I was talking about ghost records, right? Now look at Mary, for example. Mary deleted her account. She's no longer a part of your e-commerce business, but still your warehouse has her record, right? And when you use this data to build dashboards, do you think you're getting accurate results? Of course not, right? So this is another flaw of incremental load, where once you delete a record in your source system, you cannot actually track that change in your destination. So Mary is still going to be present in your destination as a ghost record, and when you query this when you query this table or this database, you're not going to end up with accurate results. So this is where change data capture, or CDC, is going to help you track changes. So next up, I think we'll start talking about CDC, right? So now let's just go ahead and understand what change data capture does and what it achieves, right? So like in the previous section, I told you guys about incremental load and the problems that it has and how it creates ghost records, right? So, and also another problem with incremental load is that you are following a process, so you have to run pipelines every now and then to update your destination, right? So what CDC basically does is it actually kind of tracks the changes in your source system and then reflects it back to your destination. So the basic idea is CDC actually doesn't read the records in your source system, but what it does is it instead reads the commit logs, right? The transaction logs that are happening in your source system. So it kind of it's kind of like a stream, or if you guys have used Kafka before, then it's something like that, where you're streaming your transaction logs or the changes that are happening in your source system to your destination, where the the modifications are allowed to happen. So in order to do this, we use Debezium. So you can see that a Debezium acts like a Kafka, like it actually tracks changes in your source system, that is maybe in your OLTP system. It tracks changes, and then through Kafka it actually streams those changes into different topics. And maybe you have one topic for table A and another topic for table B, and then those tables can subscribe to these topics and get the necessary transaction logs. So this is one way of doing CDC and like recording changes that are happening in your source system. So like I said before, when you had that ghost record problem, right, when you had that delete happen, what happened is that that record that got deleted wasn't, the information about that deleted record wasn't reflected in your destination, right? So what you can do with CDC is you can create maybe like a flag or a status. Like I'm going to show you like a practical like practical way of doing it in Snowflake, where you can implement something called as streams, so that you can understand what's really happening. So let's go to Snowflake, and I'm going to like show you guys exactly how this works, right? So first things first, I'm gonna like create a database just for this demo. I'm just gonna call it maybe stream demo, and then create a schema under this, maybe called maybe I'm gonna create a schema called stream schema, right? So now what we can do is, let's just go ahead and create a table, right, just like how it would be in your source system. So I'd say create table employees, and then I would say ID is int, and then name is maybe string, and you have your role also a string, and then your salary can be int, right? So let's just go ahead and create this table first. So this is done. Now let's just add some records like into this, insert into employees, values, I'd say maybe 101 John, or maybe Alice. I'd say she is an engineer. Her salary would be maybe like 100,000, right? So this is the first record. Then you have your second record, which is maybe Bob, and then could be marketing, and maybe his salary is around 90,000, right? Next record could be maybe like Charlie. His role could be sales, and then maybe his salary could be 85 grand. So yeah, let's just insert these three records into this table. Alice, you gotta use single quotes. Sorry for that. Okay, so now you've inserted three records, right? Let's just check employees right now. So yeah, you have these three records, right? Now you want to track changes that are happening to this table. To do that, you do something called as a stream in Snowflake, which is basically like I told you, that it's going to track the transaction logs, and then it shows you some kind of metadata related to those changed fields. So let's go ahead and create a stream now on this table. I'll say create stream, maybe let's just call it employees stream, and then on table employees, right? Okay, cool. So let's just create the stream first. So cool, now since the stream has been created, now this stream is going to track all the changes that are going to happen in this table. So what we can do now is we can go ahead and insert another record and see if it is tracking changes, right? I'd say insert into employees values. I'll just say 104. David, maybe his role would be an intern, and then his salary could be maybe 50 grand, right? Cool. So we have an insert operation successfully completed now. Now let's go check our main table. As you can see that David has been entered into this new table, right? Now, if you want to check what happened, if you want to check the stream, right, that's basically tracking this, so-called, what do you call this, the so-called table, what you can do is you can do a select on that stream to see if it's tracking those changes. Select star from, what was my stream called? Okay, it was called employee stream. So now when you run your stream, look, it has different metadata fields, and also like action, is update, and row ID. So basically it has the row and it also has what action was performed when this row was entered, right? When this row was processed. So we can see that it in the metadata.action, it clearly says that this was an insert operation, right? And I'll talk about update later, so we can, basically when you do an update, you're basically deleting the already existing, record, and then you're replacing that record with the new record. So you're basically doing a delete and an insert. So when you do an update, the is update is going to be true, and then you'll do both the delete and an insert. I think I'll show you guys, like maybe I'll do an update operation, right? Maybe I'll do like update, I'll do update like employees, maybe set the salary of Alice to maybe 200 grand. Maybe she got a promotion, right? Set salary is equal to 200,000, where the ID is equal to 101. Right? So now if you go and look at the original table, you see that Alice's salary has increased to 200k. Now if you go and check your stream that was capturing all the changes that were happening, you'll see that you have two records, right? One was an insert operation where it says insert metadata action is an insert, and then an is update is also true because we were updating the record, right? So it was set to 200k, but the old record, the old Alice's record, which was set to 100,000, got deleted, and again it was a part of the metadata, the update operation, right? So this is how you're constantly tracking the changes that are happening in your source table. Now you can also you can also like do a delete operation. I can just show you guys that employees where maybe ID is equal to 104. Maybe we want to get rid of not David, let's say we want to get rid of Charlie, right? So now if we do like a select from employees, you can see that Charlie has been deleted from the table. Now if you want to like so if you want to go ahead and look at the stream that was recording your changes, go to employee stream, you can see that Charlie has been deleted, right? The change has been recorded in the stream. Now how do you use this this metadata columns to actually go ahead and let's create another destination table, right? I'd say I just copy this. I'll call it employees dest. Okay. Or else let's not create a destination table. Let's just work on the original table itself, right? Or we'll see what we can do, right? Or maybe we let's just keep employees dest. So now what you can do is you can create a merge operation, right? You can see the you can basically get the big picture by doing a merge operation. Let me just show you how we can do a merge operation. So you would do merge into employees destination, which is your destination, and here you would do maybe T, right? Let's say maybe T as target, and using your source table, which is your not your source table, that's your transaction log, which is your employees stream, right? As maybe S on which column do you want to use to, you know, apply your changes. We'll go with ID, right? Because ID is what is like uniquely identifying each record in our table. So we'll go tr.id.s.id, and then what we can do is, this is going to be case 1, right? So it's the delete logic. We can call it the delete logic. Basically we deleted Charlie, right? So we have to somehow give Charlie a flag called delete. So what we do is, when we do metadata $action, we can say when matched, right? Because you're matching the two IDs. So what we can do is, when matched and when metadata action is equal to delete. So where am I getting this metadata action is from my stream, right? If you want, like, I can show you guys that thing. Yeah, so this is the column that I'm referring to here when I say metadata.action. When metadata.action is delete, and when it is not an update. Remember, when you're purely doing a delete, your isUpdate is going to be false. Just like how Charlie's record got deleted, but the update was false because we're not doing an update, right? So what we can do is, and we can use, like, so since we're using aliases, we can do like s.metadata.action, right? So we can do something like this, equal to false, right? When you can do something like this, and now what you can really do is, you can, if this is true, right? If this is true, then what we can do is we can do a delete. But when matched, and let me just copy these because we're going to be using this. When we're doing an insert, and when we're doing, let's say, what do you say, when we're doing an insert, and when the isUpdate is true, that means we are doing an update, right? So then we can do an update operation. You set the new name to the stream.name, then you have the role, right? You have the role here, g.role is equal to s.role, and you have t.salary, right, is equal to s.salary. Now this is the second case when you're doing an update. This is case 2. This is your update logic. And then you have your third case when you're purely doing when you're purely doing an insert. So when you're purely doing an insert, you can't do when matched, right? Because you're inserting a new row. Obviously the new row's ID is not going to exist. So this is going to be an insert, right? So here we'd say when not matched, and the same thing is equal to insert, then we would do the insert operation. We have the 4 columns, that is ID, name, role, and salary, right? So the values would be from the stream, that is s.id, comma, s.name, comma, s.role, and s.salary, right? So this is how you can do a merge into the target table. Let's just run this and check if everything's all right. So the number of rows that were inserted was 2. So let's go ahead and see why it was only 2. Select star from employees list. So you only have Alice and David, right? So now let's check our stream. Our stream was this one. So now your stream's results, after you have ingested everything from your stream, you really don't have, like, you know, your stream becomes empty. So this is one property of Snowflake that you all got to remember. I don't know how it is in other services, but this is how it works. So what basically is happening here is, you know, you did your insert and also you did your update. So these two records got inserted. So these two records is where the changes happened, right? Now we didn't change anything else, right? We just deleted Charlie, which is of course we don't need Charlie, right? So this is how you can do your this is how you can track your changes, right? You changed Alice's salary, and it's there in your destination, and you also inserted David. So now you have you have David's record here. So this is how you can do this is how you can implement streams, and this is a basic idea of how change data capture works, right? Now let's go ahead and discuss some of the pitfalls of so now sorry guys, I had to go do something else. So now you can see that you only have 2 records, but why don't you have Bob, right? The reason why you don't have Bob is because of a flaw of CDC that I will discuss in the next slide. You can see that you can see that in your source table you had Alice, Bob, and David, but in your destination you only have Alice and David. So where's Bob, right? So this is where I think this is the right time to talk about the flaws related to CDC. So the first challenge that you will have to face with CDC is operational complexity, right? So you have to go and enable database commit logs, and you also have to talk to database administrators or software engineers that are designing how data is collected from a system. So you'll have to, like, talk to them and ask them for access to, you basically have to ask them for permission to access logs, and you also have to ask them to generate logs in such a way that you can easily read them and stuff, right? So all this is kind of a challenge where you have to go and talk to different people in your workplace and get things done. Next is this is the point where Bob, this is the challenge where Bob did not appear in our destination table. So when you enable a stream on a data, it starts recording the changes only from that very moment, right? But when we created, you can look at you can look at the code again. We created the stream only after we inserted these 3 values, right? So when we created the stream after we have entered these 3 values, and after that we did not do any changes with Bob. This is why I didn't want to do anything with Bob, because I wanted to show you guys this flaw that CDC has, right? This challenge that you would face. You are not going to see a record that was there before your stream was created and it was untouched, right? So now what happens is that to, you know, like to overcome this challenge, what you can do is you can copy all of this to your destination table and then do your merge. But again, is this the right way? Not all the time. So what I want to say here is that your stream will only start tracking, you know, it will only start, you know, tracking changes after you have enabled that. Whatever records that you had enabled before are not going to appear in your final destination table if you keep them untouched. Alice and Charlie appeared in the, I'm sorry, I think it was Alice and David. Yeah, so Alice and David appeared in your final destination table because those records had been altered with, right? Those records had been altered. So we deleted Charlie, and we also, I think, updated Alice's, you know, salary from 100k to 200k. So this is one consideration that you have to keep in mind. And also it comes down to complex payload, right? So when you get data, if you look at the stream, I can show you, like, maybe do I can mess around with Bob right now. I'll just say, let's change Bob's salary to 100 grand, right? Now let's just check our original source table. So you can see Bob's salary has changed to 100 grand. Now let's check our stream, which is tracking all the changes. You can see that Bob's record has been deleted, and then you're doing an insert. So essentially you're doing an update operation. So what happens here is you're not just getting a row, you're getting metadata along with it, right? So sometimes this metadata can be complex, and this requires, you know, it's usually in JSON format where you have to like parse them and, you know, try to do the necessary changes in your, what do you call, in your destination. But Snowflake does that all for you, you know. That's why I use Snowflake, just to show you guys. But if you're using another tool, then it might be a challenge. And also the last point would be the streaming semantics, right? So data is always in motion and it's not at rest. So what happens is, if you are using joins, let's say you were this is kind of complex to understand. Let's say that you and your friend decided to meet at a cafe for coffee, right? So let's say you guys decided for a time, let's say at 9 a.m. Maybe you in batch processing, let's say you arrived at the cafe at 9 a.m. but your friend did not arrive there at 9 a.m. So you just assume that your friend's not coming, right? So what happens is, the joins in that case is going to be you're gonna, if you do like a left join or a right join or whatever kind of join, then obviously you did not meet your friend, so that record will show that you did not meet your friend. Now let's say you're streaming data, right? Data can come at any time. Let's say you went to the cafe at 9 a.m. and your friend did not show up at 9 a.m. But it doesn't mean that your friend would not come at all. Your friend could show up at maybe 9:10 or 9:15. So if you implement this law, if you just assume that your friend is not coming, and if you just do a merge, then you're not actually inserting the accurate results in your destination table. I hope you guys could understand what I meant to say, right? Your friend could come at 9:15 or 9:20, and only after your friend has arrived is when you can, actually do the join and then merge the results into your destination. So this is something which is very complex, and this is what makes joins difficult when you're doing CDC. So now since we modified Bob's data, let's just go ahead and run the merge operation, and let's see if his record is being you know uh, his record is being displayed when we run the select star for the destination table. So yeah, here you go, you can see Bob's record now in the destination table. So again, only after that you've created your stream is when it starts tracking your source table, and so you have to be very mindful of that. And yeah, so this pretty much sums up what change data capture is, and that's it for today. And I will be covering more such concepts in the future. But the thing is, I know these were pretty foundational and these are pretty basic ones. I think in the next video we can start talking about replication, which is really interesting, and how we can overcome certain challenges. So I know, guys, my audio quality and my PC has been bugging a lot, so I hope you guys can forgive me for that, because I'm actually moving places and I have to disassemble my entire setup, and that's what I'm doing right now. And I promise you guys that things will get better in the future, and we can learn some really interesting stuff together. So thank you, guys, and if you have any queries or suggestions, you can drop them down in the comment section. And you can also go ahead and follow me on LinkedIn, and that's the only place where I'm at, I guess, because I quit social media, and I really don't use a lot of social media apart from Reddit. So you guys can text me on LinkedIn too if you have any queries, and then I'll be happy to respond. So yeah, I hope you guys have a good day, a great day, and I'll see you guys in the next video. Thanks.